Hi, this is Mrs. LaBarbara. This is Physics, Chapter 4, Two-Dimensional Motion and Force, Video 2. Today's topic is describing projectiles with numbers in velocities and displacement. Notice I have S here. That is because projectile has two dimensions, has X and Y, X velocity, Y velocity, X displacement, and Y displacement. The objectives are to know motion, projectile motion is two-dimensional motion, understand the symmetrical nature of projectile launched at an angle, be able to determine the horizontal and vertical components of velocity, and be able to determine horizontal and vertical displacements, compare horizontal and vertical speed and acceleration at different points in a projectile's path of travel. Let's first talk about velocity. So we can use kinematic equations. So this is kinematic equations in one-dimensional. Now projectile has two dimensions, so we have to use the horizontal only in horizontal motion and the vertical components only in vertical motion. So here is horizontal, acceleration is 0, so basically the second part disappears. Vx is constant. In the vertical, AY is negative 9.81, so this basically becomes VIY minus negative 9.81 times t. So what this equation tells us is a velocity in the horizontal direction is constant. In the vertical direction, it changes by negative 9.81 meters per second every second. So that means if the projectile goes up, it will decrease by that amount, becomes 0, then it comes down. Well, it comes down since it's in a negative direction, so its speed will increase by 9.81 meters per second every second. Again, please be very careful when you apply the equations. Only use the components in your equations. Only use horizontal component for horizontal direction and a vertical component for vertical direction. Let's take a look at our first example. A cannonball is launched with a velocity, horizontal velocity of 73.1 meters per second and a vertical velocity of 19.62 meters per second upward at time t equals 0. You need to fill in the blanks. So first of all, we know horizontal acceleration equals 0 for every single point. Vertical acceleration is also constant, which is negative 9.81 meters per second squared. Horizontal velocity is constant, is the same as the initial horizontal velocity, so 73.1. Vertically, it decreases by 9.81 meters per second while go up, becomes 0, then increase. So initial velocity is 19.62. For every second, it decreases by 9.81. So at 1 second, it becomes 9.81. At 2 seconds, it becomes 0. At 3 seconds, will increase by 9.81 going downward. Then increase again by 9.81 downward. Then you just simply add 9.81 for each second. You come down. Let's take a look at this example. An object is projected horizontally from the cliff. So here is the path. The diagram represents path. How does the magnitude horizontal component of velocity at A compare with horizontal velocity at B? We know horizontal is constant, so they are the same in the horizontal direction. How does the magnitude of vertical component of velocity, the vertical at A compared to vertical at B? Since the projectile is moving downward, so its speed is increasing. So VB is bigger than VA. Now on the diagram, sketch a likely path of horizontal projected object, assuming there was air resistance. Remember, air resistance shortens the horizontal distance, so it looks like this. Now let's talk about the displacement. So horizontal and vertical motion have the same time. This time is the same. In the horizontal direction, ax equals 0, so horizontal is moving with constant velocity. In the vertical direction, if you don't have a, it will just keep going up, but you'll have downward acceleration, so it's kind of drag it down, so you have to subtract. So this one is add since ay is negative, so you have to subtract this component for free fall. So again, only use the horizontal component. For the horizontal direction, only use vertical components for vertical direction. Let's fill in these blanks. So here are the examples. Again, we know ax equals 0, ay is negative 9.81. So for Vx is a constant. For Vy, we did that already. We change this by negative 9.81 for every single second. Dx is Vx times the time. So in the beginning, it's 0, 73.1 times 1 give you 73.1, 73.1 times 2 give you 146.2, and so forth. So basically, for each second, you move by 73.1 meters for every second. Now let's talk about dy. dy, how do we find dy? We use the equation VIY, which is this, VIY times time minus 1/2 ay times t squared. So these are the value you would get, 0. How did I get 14.7? I used VIY 19.62 times 1 minus 1/2 times acceleration negative, plus 1/2 times negative 9.81 times 1 squared. That's how you get 14.7. This one, you do the same thing. dy equals to VIYT. What is VIY? 19.62 plus 1/2 times negative 9.81 times 2 squared. That's how you get dy. And for each second, you just substitute different time. As you can see in here, the symmetrical nature of the projectile. So in the vertical speed is the same, but the direction is different, right? This is 0. So 1 second before 0, the top most point, and 1 second after the peak, they are the same speed, but opposite direction. 2 seconds before the peak, 2 seconds after the peak. This is displacement. This is the peak 1 second before and 1 second after have the same height. And similarly, 2 seconds before and 2 seconds after also have the same height. Horizontal and vertical components do not affect each other. So horizontal and vertical velocity are independent of each other. The horizontal velocity of the projectile does not affect how fast the projectile falls vertically. Take a look. These are 3 horizontally launched projectiles. The difference between them is the initial horizontal velocity. This one has the smallest, the medium, the biggest horizontal velocity. So changing horizontal speed does not affect their vertical motion. Since all 3 projectiles have the same initial vertical velocity, which is 0 because you launch it horizontally, they all have the same vertical acceleration, negative 9.81 meters per second squared. They also all have the same vertical displacement because the table have the same height, is the same for all 3 projectiles. So all 3 projectiles will have the same amount of falling. All 3 projectiles will fall with the same time. Let's take a look at this example. A projectile has an initial horizontal velocity of 50 meters per second and an initial vertical velocity of 25 meters per second. Determine the projectile's horizontal and vertical displacement if the total time of flight is 5 seconds. So this is really kinematic problem, except now you have horizontal and vertical. So first, you make a chart. It's very similar to how you did one-dimensional. You just add another dimension of y. Then you write down what you know. This is horizontal 15, vertical 25 initial velocity. You also always know the acceleration. In the horizontal direction, it has 0. In vertical direction, it has negative 9.81. Another thing you know is the time. Horizontal and vertical always have the same time. Now to find horizontal displacement, you use that equation. VIT plus 1/2 AT squared. A in the horizontal is 0, so I didn't write it. So it's just VIX. You'll have to use X component, which is 15 times the time. Horizontal is 75. Vertical, you use the same equation except use Y component. VIY is 25. AY is negative 9.81. You'll have 2.38 meters. Basically, it goes up and comes down. Another example, so a baseball is dropped off a cliff and it accelerates to the ground at a rate of negative 9.81 meters per second squared, downward. Meanwhile, a cannonball is launched horizontally from a cannon with horizontal speed of 20 meters per second. Fill in the table below. First, let's talk about baseball. Since the baseball is just dropped, it has no horizontal displacement, so all horizontal is 0. In the Y direction, we write down, again, make a chart. Initially, it has a 0. Velocity acceleration, we also know, let's just do for 1 second. For 1 second, you plug in the equation with 1 second. So you get negative 4.9. Then for 2 seconds, you plug the time in 2 seconds. And similarly for 3, 4, and 5, you will get this a number. It's negative, it means it's going downward. Displacement is downward. For cannonball, you'll have both horizontal and vertical directions. So you make a chart with 2 dimensions. You fill in what you know. Horizontally launched 20 meters. Horizontal acceleration is 0. Let's calculate t equals to 1 second. So x equals to this. A equals to 0 equals to 20 meters. T equals 2 seconds, you simply plug the time equals to 2. Similarly for Y, this is for 1 second. For 2 seconds, you put it time equals to 2, 3, 4, and 5. So this is what you get for X and for Y. As you can see, Y have the same. This is again further saying X component does not affect Y component. Y component are the same, even though X component are different. Okay, that's it for today. I'll see you next time. Thanks for watching.